Good afternoon. I'm going to talk about work that I did over the past 7 months. I think some of you know me, maybe some of you don't. My name was already mentioned a few times this morning because I'm one of the main authors of the spec book. And when I was working on that, I had to postpone a large project that I was working on. I was working on a new browser for Faro, written in spec, but at some point, Stefan came to me and he asked, do you want to work on the spec book? And then I had to postpone the project for 7 months because that's how long it took. And during writing the book, I was thinking about how do you test spec applications? And in particular, how would I test my browser? How would I write down a specification and have documentation afterwards? That is what all this started, what Hera started. During this presentation, I will show you a few videos about how it works. It's possible that it goes very fast because I only have 30 minutes, including questions. If you want to see the videos again, then please go to my blog. The article at the top is the one that I published this morning. It includes all the videos that I will show today. Okay, so let's go. The title is Behavior-Driven Development with Hera. This is definition of BBD, as it is called in short, but I will not read the slide out loud. There's too much text on it. Important is what I indicated in bold. BDD is a good way to let non-technical people and technical people work together and understand what they want to do, what they want to achieve, and how we implement it. And also very important is that we produce specifications that can be executed so that we can run them as a test, like we run a unit test. Yeah? And that when we have that test and it's green, that we have documentation afterwards about the behavior of the system. Now, I didn't start from scratch, of course. There is a well-known, let's say, technology. It's called Gherkin. It's a way to write specifications or executable specifications. And as you will see in the examples that I will give, it's very simple because it's basically plain English with a few keywords in it, and the keywords give meaning to the lines that you see in a script that is the specification of the system. So let's see. We will use this example here. We will, the finder in Faro, and we will describe it in Gherkin. That's what we will do. On the left side here, you see what we want to, oops, that was the wrong one, excuse me. Push the wrong button. I'm too close to the thing here. Okay, so where's my pointer? Here. Okay, what you see here is you select where you want to search. It's the search mode, as it is called. Then you have the input field to enter your search string, and you have the search button. And when you press the search button, you see the result here, and you also see it here. Yeah? If you'd like to describe that in a Gherkin script, then we do it like this. I will not explain everything about Gherkin because then I need at least an hour. Yeah? So I will explain things as we go. Yeah? What you see here is a script which describes a feature, and a feature has a title. A feature collects a few scenarios, and every scenario has a title as well. And every scenario consists of steps. And as you can see here, there are 3 types of steps: a given step, a when step, and a then step. This is a description of the behavior for finding in the source code of Faro. But if we have here we have an example, which is a variation of that, where we search for selectors, as you can see here. And we search for a selector, we press the search button, and then we find a lot of hits, as you can see here. We can describe it like this. You see that the first step in the scenario is the same as the other one. We open the Finder window, and then we search in selectors for @, and then we see so many matching methods. That's what we will use as an example. Let's elaborate elaborate a bit about the steps. So there are 3 steps. First of all, we have a given step. A given step typically states the initial state of your system or the context, yeah? Things that have to be set up before you do before you execute the other steps. Then you have the when steps, and they specify an action or an event. The action is typically an action by a person, so a user, yeah? But it can be an action by an external system, for instance. And then we have then steps, and the then step states observable behavior. And with observable, I mean observable by the user. Yeah? So that means something that you see in the user interface, an email, for instance, a report, a log file, stuff like that. Definitely not what you see, because you can't see it in the database. A user doesn't see the contents of the database, so never write a step like, I have this object in the database. That would be very, very bad. Okay, given when then should trigger a bell, because in unit testing you have that pattern AAA, right? Arrange, act, assert. That's basically what you see here. Okay, now when we write a scenario or we write a full feature, we write a script, it's just text, right? And we have to make it come alive, we have to implement the steps. Yeah, we have to give a definition for the steps. That's what you see here. We have those 2 scenarios or the 2 feature files, as you can see, the 2 scripts that we had before, and this is an implementation. What we typically do is we implement those steps in the programming language of your choice, right? In here, I used pseudocode, or it looks like pseudocode, but actually it's valid Ruby syntax. And as you can see here, we have a step implementation or a step definition on the right for every step that we see on the left. There is some reuse, as you can see here, because that given step there, we have only 1 implementation, of course, because it's the same. Okay, now the question is, yeah, if we have those steps in our script and we have those step definitions, how are they matched? Well, there are 3 ways to match steps. I will show you 2. There are 3, but I will show you 2 because of time pressure. First of all, we have an exact match. That's the most simple way of matching a step with a step definition, because we just match on the step description, as it is called. So for instance, the finder is open. Yeah, we have to find a definition with that description, and it's not there. Well, I should take the other one, excuse me, because I didn't include it. Here I see so many matching methods, right? And here I have the same. Yeah? So that's an exact match. It's very easy. Yeah? Now, of course, you see the similarity between what we see here and what we see there. Yeah, and even the other step, it's fairly similar, right? So that means that immediately as a software developer, you say, we should make abstraction of that. So yeah, we can. Yeah? We have arguments. We can add arguments to our step definitions. And one of the arguments that we can give is what they call cucumber expressions. And a cucumber expression is something that looks like this. Yeah? Something between braces. So an identifier between braces. And the identifier that you see here is actually the type of the thing that you expect, yeah? Or that you want to have in your code. So for instance here, when it says, I see int matching methods, then this quantity argument of this block will have an integer, a real integer object as a value. That's the ID. And the same here for word and string. String is a bit special because it matches something between quotes, yeah? While word is just one word. There are different cucumber expressions, as you see there. Yeah? There's a special one here at the end, is the empty one that matches anything. Yeah. Okay, good. Now, so the cucumber expressions were a way to add arguments to your step definitions, but sometimes you need more structured data or more structured arguments. And that's where data tables and docstrings come in. As you can see here, a data table is something that we write with vertical bars so that you really see all the cells in the table. A docstring is written with these delimiters, a triple quoted string, as you can see here. And then this example, which is not a finder example, says that we have a step here when I select all this. So that means I select this package, that tag, the class, and in the middle of this, then I expect to see this source. Yeah? That would be a behavior description of Calypso, for instance. As you can see on the right, when we have a data table of or a doc string, then immediately we have an argument in our method. That's what you see there, a data table argument or a doc string. Okay, so that's Gherkin, or at least that's the part of Gherkin that I want to show you, because of time constraints. Now let's see how we run a Gherkin script. And we do that with a Cucumber. Cucumber is a tool, it's a command line tool. It's typically used in systems with, well, file-based programming languages, that's what it is. And it's a tool that matches what you see in your script with the definitions that you find in your implementation. That's what it does. Now, there's a lot of language support for Cucumber because Cucumber has plugins for every programming language that you would like. And as the previous slide said, you can choose your favorite programming language. Now, what's your favorite programming language? Yeah, okay, otherwise you wouldn't be here. Look at the slide, it comes from the website. Smalltalk is not on here, yeah? And that's why I implemented Hera. That's why I implemented Hera. Okay, so what is Hera? Hera is a set of tools, and I will show you I will show them in action. It's a set of tools to write and run Gherkin scripts, yeah, so feature files, let's say. But the scripts themselves are not stored as text. In a file-based system, you save them in a text file. Yeah? In Smalltalk, you don't. Yeah? So we capture them differently. We capture them as object representations in methods. You will see it later on. So that means that we have what I call feature methods. Yeah? And those feature methods are put in classes. Yeah? They're put on classes, and in Hera it's called an acceptance test class where you put it on. And then you have your step definitions, of course, and they map on Smalltalk methods. Yeah? It's as simple as it is. Yeah? And then, of course, Hera is able to match what it finds in a script. It can match it with the step definition, right? And then it runs the script. Yeah? So, in fact, Hera is a Cucumber for Faro or for Smalltalk, because it's not, I mean, we can do it in any Smalltalk. Okay, these are the three tools that are currently available in Hera. This is still under development, yeah? So this is what the state is today. Let's have a look. First of all, we have the Hera feature browser, as it's called here, where you see the classes and the features here. This middle thing here is called the script editor. That's where we write the script. And here on the right side, this is the step editor. That is where we edit the steps, where we give a definition to our steps. Then we have the Hera runner, as you can see here. And the Hera runner pops up as soon as you push one of these buttons. This is the run button, yeah? And then you can run the full feature. And we have a bunch of steps, as you can see here. I didn't talk about the end steps yet, but anyway, I'm not going to do it. What you see here is a Hera step browser. That's actually a view on the catalog of steps that you have in your system. Yeah? And as you can see, it's ordered by type of the step, as you can see here, or you can see them all, and there is some other functionality that will be added later on. Okay, how do we store the features then? As you see here on the left, that's our feature, our script, and that is how it is stored in Smalltalk. Yeah? So we have a method selector, of course, and then this method has a pragma. It's called Hera feature, and it has one argument. It's the title of the feature. And then the method returns an object representation of what we see on the left. And that's the reason why we don't have to store the text, right? Because from this object representation, we can generate that text. You will see that in the demo that I will give. That's a feature method. Then we have step definition methods. And yeah, it's similar, of course. The method has a selector. As you can see, the selector could have arguments, as you can see here in the middle and at the bottom. Yeah? And then there is a pragma in there, Hera step definition, and it has an argument, and that argument is an array. And the first element of the array is the step type, so given, when, or then. And then the array can have a length of 2 or a length of 3. If it has a length of 2, that means that we have an exact match. If it has a length of 3, then we have a match with arguments, and that's what you see here, for instance. Then there is an extra symbol in that array. Okay, good. Okay, so now I'm going to show you 13 videos, right? They are short, short videos. One is longer than the other, but 13 videos to show you how it works in practice. So let's just start, right? What do we do first? We create a new class. We put it in a package. And then we press that button. We give the title of the new feature. And we press accept. And then this happens. Yeah. You see here in the middle, the script editor. It contains a valid Gherkin script. There are no scenarios, but it's valid Gherkin scripts. Okay, so let's add our first scenario with the first step. There we go. There's the scenario. Okay. There is something that you should notice. I pasted in the text, then I saved, and then it formats automatically. So you don't have to worry about formatting. It will be done automatically. And as you can see here, Hera, or the script editor, indicates that new step with an underline, a blue underline, which means, I show it here, the script has no definition. When we see that, that's a trigger to implement the definition. So let's do that. Oh, I was too fast, was I? Excuse me. Let's go back. There we go. Oh, sorry. Yeah, I should use this tool better. Okay, so this is the next slide. And we already implemented it, as you can see it there. Yeah? And then we run the feature, and then the Hera runner pops up, and it shows the result. It passed, but the strange thing is, it passed, but you didn't see the finder, right? Because it went so fast. It was just opened and closed. You didn't even see it. Yeah? So that's annoying, and that's why we have a special step, and it's called the pause step. And we can add a pause step to our script. Yeah, I don't know what I'm doing here. I pressed the wrong button again. Excuse me. Okay, so here we save. I will let it run. Sorry. So we close it, and there we go. Yeah. When I pause, special step. Good. And when we run the feature again, then we see this. So then the Hera runner stops at the pause step, and then you can inspect the user interface, yeah? Or your application in general. It could be more windows, right? Okay, good. So this is nice. And we can use that to elaborate our script. We keep the pause step in so that at the end, we immediately see what the result is. So let's go to the next one. I said the next slide. Okay, let's add a new step. The next step that we want to add is we want to search for something. So we save, then we have to implement it. I clicked on it, then this comes up. I will immediately explain what it did. And then we implement the step, right? So what happened? I added the text, I saved the script, then it was the blue underline was there, then I option clicked on it, and when I option click on it, and the step is not defined, then it will ask for the selector for that method. The suggested selector was fine. It's based on the step description. So I confirmed that, and then it showed up there. It was empty, of course, because Hera doesn't know how to implement it. Then I added the implementation. I saved it, and we are in that state. Yeah? So did it do something? No. Okay, so we run it again. As you can see, it opens the window. It keeps the window open because the pause step is still there. So there we are. Okay, and now I have to use my glasses here. Okay, good. So what we see here is that we are developing that script incrementally, right? We add a step, we implement a step, then we run the feature, and we keep it green. That's the idea. Yeah? Okay, so now let's add another step. Watch. We are going to add a then step. to verify that the contents of the finder is what we expect. That's what you see here. I paste in a step with a data table. I define it, then I implement it. Now I'm going to stop for a second, right? So I implemented this. This code is a bit more complex. There is a loop in here that checks that what we have in the data table corresponds with what we have in the user interface. Now we can run it, and there we are. We can have a look at the contents, and you see here that the contents of the finder corresponds with what we have in the data table in the script. That's why the test was green. Okay, good. Let's go on. I like to work in a red-green refactor pattern or rhythm, right? So we had a red test in the beginning because it didn't work, then it was green. Yeah? And what about the refactoring part? Well, if you look at the script, the script that we have there, then there is something special about the when step. So I will continue with the demo, but I will stop. We first take out the pause step, and then we option click on the when step, and then I will pause the video. Yeah? So what you see here is that we hard-coded the selector. Where's the mouse pointer? Yeah, we hard-coded that selector that we are looking for, right? But it's clear that if you want to search for other things, that it would not be a good idea to hard-code it, right? So let's continue with the script, and you will see that there is a refactoring step here. Yeah? We just change the selector of the method. We add an argument, and that means that we have to add an argument to our definition there, and we use a cucumber expression, right? We indicate that we have a match with an argument. Then we use that argument, and we save. And then we get a question. I will talk about it immediately. So it will be confirmed. That's it. And then we can run, and it's still green, right? So we did the refactoring. We only changed the definition of the method, or the step method. Yeah? We didn't change the script over there. Yeah? But now we have a reusable step, because now we can use that step definition here to search for other stuff. Yeah? The question that popped up was a question about, do you want to replace the method that is already there? And I confirmed it because I want to replace it, because otherwise I would have two methods that have a definition for some steps, and that would be confusing and ambiguous. Okay, let's add a second scenario then. As you can see, there are two more steps that are not implemented. So we option click on it, then it's there. We use, oops, I will stop here. We use an uncheck helper. As you can see here, it's part of Hera. And there is also a check helper. So I will stop. It's a simple helper that, as you can see, this is just a path to the presenter that we want to manipulate. It's a checkbox. So that's it. Then we run. And oops, what happens here? We've got an error, as you can see. It says here, presenter with name finder is not found. Yeah, and that's, of course, logical, because when we have a look at the script again, and in the first scenario, we open the finder, but in the second scenario, we forgot that, right? So we have to open it. Now, by now, it's very clear that if every scenario that we write, we will need a step to open the finder. So it would be better to abstract that somehow, and that's possible because Gherkin allows you to add a background section to a feature. It's like a setup in the unit testing framework. So let's do that. So we take out that given step from the first scenario, we add a background section with that step in it, and we run, and it's still green. Yeah. So now we did a refactoring at the script level here, right? To be clear, when you have a background, then when we run any scenario, the background will be executed first. Yeah? And I don't know whether you saw it, but in the Hera runner, it is indicated that it is a background step. Okay. We are going to add a third scenario. It's the last one. And you will see that there is an extra step in there that we don't have, as you can see here, when I click case. So when I check case, excuse me, I can't read it from here. So there is another checkbox that we manipulate, so we have to implement that step. We do it by option clicking it, then it's generated, we implement, I will stop. Now we implement it like we did before. Now everything is implemented, and now stop. Yeah? I'm going to run a single scenario. So with the button at the top left there, or on top of the script editor, we run the whole feature, but we can run a single scenario, as you can see here. We will just select run scenario, and then we will run that only scenario. That's what you see here, right? Now, we can do more here. I will press restart. We will move the window first. We press restart, so the Hera runner allows you to restart what was already there, so we will restart that full scenario. But instead of running it completely through the end, I will step through it, and I do that with the step button, as you can see here. So this allows me to execute step by step, all the steps in sequence, inspect the user interface, manipulate it maybe, do whatever, or debug it. Yeah, you can all do that. Yeah, that's it. Okay, good. Then there is a final thing that I would like to do to finish up. That is, and maybe you didn't notice, but let's have a look. When we implemented, when we implemented the methods, then you have to specify the type there, and as you can see, the type corresponds to what you see on the left, what's being clicked. But for the end steps, you will see that it is not correct. Yeah, it's there given. That's because Hera, at this time, cannot know that end that you wrote there is a when, a given, or a then step. And that's why we have to fix that. And once we have fixed that, and now I have to watch out. Once you have fixed that, then we can open the step browser. That's what you see here. And then those step types can be used in the step browser, as you can see here, to indicate the given steps, the when steps, and the then steps. Yeah? That's it. Those were the videos. Okay, what is the current state of Hera? First of all, Gherkin compatibility. It almost implements the whole feature set of Gherkin. There are a few exceptions. That's what you see in the red boxes over here. There is also a scenario outline. I didn't explain it, but it's not implemented. And we have free-form descriptions in Hera. So below a feature, below a scenario, and below a rule that I didn't mention, we can add free-form descriptions because there is no keyword at the beginning of the line, and we can write whatever. So that means that you can add more description to your feature or to your scenario. That's also possible in Gherkin at the background level, but it's not implemented yet, but it will be soon. What is not supported are comments. Gherkin supports comments with a hash sign at the beginning of the line. I chose not to implement it because it pollutes the abstract syntax tree. And I don't want to bother with it. That's the idea. And we have free-form descriptions where you can put anything that you like. There is also one technical limitation today, and that has to do with modal dialogues. When a modal dialog pops up, it blocks the user interface, and that means that it also blocks the Hera runner. So that means that we cannot manipulate, we cannot continue running the script anymore. In Pharo 14, very recently, some testing capabilities for modal dialogues were added. Very interesting. Christophe, who gave the presentation about spec this morning, will give another presentation about testing spec applications on Thursday, I believe. Then he will explain how that works. I asked to backport it to Pharo 13, and it has happened, I think, last week or the week before. So that's nice, but we cannot use it in Hera. That's a pity, but anyway. So that's a technical limitation. You cannot write or you cannot specify the behavior of the internals of a dialog. Okay, what are the next steps? Yeah, there are a few. First of all, gathering feedback. That's why I'm here. So if you have feedback, please tell me. Better integration with the Pharo tools. I think it was Stefan, are you here? Yeah, who said, yeah, I like to open the feature browser from the Pharo browser when I select an acceptance test class. He's right. I would like to have more refactoring support, not only at the step definition level, but also at the script editor level. And Stefan was already dreaming out loud about refactoring because he's busy with refactorings in Pharo. So this could be a domain-specific refactoring, something like that. I like to have CI support. I already run some scripts on CI for Hera itself. but I have to document it better. Then I would like to elaborate the domain-specific language, as I call it, for interacting with spec applications, so that you know how to, as you saw, uncheck and check a checkbox or select a radio button or fill something in, something like that. Yeah? It's all work in progress. And then I like to use Hera on a wider scale, and actually I'm already doing that at a big company with a lot of Smalltalk developers who have a problem of having a very large stack of manual tests, and they like to automate them, and this tool is actively being used to do that. That's in VisualWorks, by the way. We did a port. And then that's what I started with. I like to use Hera, of course, to describe Atlas, the browser that I am working on. Okay, I added this slide just for your reference when you look at the presentation later, so that you have the links. Everything is on my blog. Yeah, a full description of Hera is there, so please have a look. And then this, of course, I give a demo at 5:30 this afternoon, because I submitted Hera for the Innovation Technology Awards. Yeah? And as a teaser, I like to add this. I didn't show you, I didn't tell you, but what I can do is I can use Hera to describe the behavior of a web application if I combine Hera with Parasol, which is a testing framework for C sites. That's it. Thank you.
Thank you very much, Jim. Indeed, a really good presentation.
Thank you.
Any questions before the coffee break?
Hi. Yes. So, two questions. So first, you show this DSL, the check and check stuff. So that means that you are mixing auto-generated code with handwritten code, or so. And I imagine, for example, if I want to use it myself, sometimes I want to add my own primitives into this DSL. So what is your idea of how is it designed, actually, that part?
Okay, so you mean the uncheck and the check primitive, for instance, and there were a few others. They are, when you create a new feature, you install it on a class, and that's typically a subclass of Hera acceptance test, as it is called. That's the name of the class, and the primitives are there. Today they are there. Maybe we will move them to a trait or something like that, but anyway, they are there so that the subclasses can see it. Yeah. So if you want to add one, you can put it there. I mean, you can put it in your own classes, of course, but if it is of general use, then you can submit a pull request.
Okay. Yeah. And my second question, before somebody else steals me the time, how would you use this to specify the behavior of a compiler?
I would have to think about that.
That's good enough.
But I mean, yeah, I expected a question like, I can do this in a unit test as well.
Well,
right?
my point is
why
that
don't you use a unit test?
My point is that we have, I don't know, 6,000 tests in the VM now,
yeah.
And it's a mess. So 6,000 different tests across many different classes, different naming conventions depending on who wrote the test.
Yes.
Sometimes the test is written in a certain way or in a
yes.
something different. So, and this kind of structures the space, and I can search for my tests.
Yes.
That's what I want. I want to structure the space of the tests.
Okay. Yeah, I understand.
So one of the important things here is that this is about the communication between users and
I understand that it's different, so it's just a mind shift.
Yes, but maybe your audience are developers.
Yes.
Yeah. So it's written by developers for developers.
For other developers.
Yeah, true. Yeah, indeed. So yeah, it's possible. Probably it's possible, right? Other questions? Mariano.
Hello, Kun. So if I understood at the very beginning, you said that the idea was to close the gap between business people and developers. And just to see if I understood, the idea is that the business people could write the features, things like find this, do that, etc. But they will still need
Wait.
someone on the developer side. Because, for example, when you define the steps, like open the Finder, the business guy would have no idea how to do Finder new.
Yes.
Or so there's seems like more a collaboration, right, between the two sides. It's not just the business alone can write it completely.
I told you that I work with a large software company, and they have functional analysts there, and they have QA people, and they have developers, all in one team. Well, they have different teams like that. And somebody writes the stories, right? And in those stories, they write acceptance criteria. Those acceptance criteria are translated into an acceptance test written in Gherkin by, for instance, the QA person or the functional analyst. Yeah? And then the QA person and the developer work together to implement the steps. Yeah? And of course, they would use the step browser to see which steps are already there, reuse as much as possible. If it's not possible, start refactoring if required and useful. Yeah, that's it. It's about cooperation between several people. Yeah.
Are there any more questions?
Come to the demo. Huh?
Okay, thank you again. And now it's time for the coffee break.